Hey there, everybody. Welcome back. We are doing 3-3. This is section D. I'm going to call this more challenging problems. So let's say k of x equals f of x times g of x times h of x. Ah, fuck it. I can even add more. Let's add like a j, just to illustrate how well this works. Rather than doing a bunch of shit, the easiest way to find d dx of k of x or k prime of x is do the derivatives one at a time, left to right. So I'll do the derivative of the first one, leaving the rest alone. In fact, maybe I'll do that part in orange. Put the derivative in orange. Then I'm gonna have, we leave f of x alone. That looks clunky. I'm gonna move that a little bit. That looks bad too. That was f prime of x. So you do the derivative of the first one and then leave the rest alone. Then you do the derivative of the second one, leaving the rest alone. Then you do the derivative of the third one, leaving the rest alone. And then you do the derivative of the fourth one, leaving the rest alone. And so this means you can have as many things being multiplied together as you want. And you just do it like this. So we'll do an example with 3 parts. Find f prime of x if f of x equals, I don't know, 4x cubed minus 2x times 3x to the 5th plus 7x squared. And we'll do negative 3x plus 1. So we do the derivatives one at a time. This is like A, B, and C. So we're going to have A prime B C plus A B prime C plus A B C prime. This is like saying A times B times C is f of x. So I will take the derivative of the first. The derivative of the first one is 12x squared minus 2. And we leave the rest alone. And then we leave the first alone. Take the derivative of the second one, which is 15x to the 4th plus 14x. And then we still have the third one there that we leave alone. And then finally, we leave the first two alone. 4x cubed minus 2x, 3x to the fifth plus 7x squared. And we just take the derivative of the third one, which is -3 plus 0. That is the derivative. Again, if you need a polynomial, if you need one big polynomial, not broken up like this, it's easier to do so ahead of time. It's easier to multiply out before taking the derivative. The reason why, in fact, it's always easier to multiply it out first with the polynomials. The reason why you need to learn this product rule really well and the quotient rule is we're going to be adding other stuff like trig functions, logarithmic functions, exponential functions, inverse trig functions, and you can't multiply that shit out like we could here. Okay? So you can't always multiply it out. You need to know how the product rule works. Very important. Another challenge problem. Let's do a product and a quotient. Let's say, I don't know, we have f of x equals 8x cubed plus 5x squared times 3x squared minus 4x all over 5x plus 1. So this is a quotient. This is my high. This is my low. So the derivative of high is a product rule. We take the derivative of the first one and leave the second one alone. And then we leave the first one alone and take the derivative of the second. Derivative of low is just 5. So we want low d high minus high d low over low squared. F prime of x equals low, which is 5x plus 1, times the derivative of high, which is 24x squared plus 10x, times 3x squared minus 4x, plus 8x cubed plus 5x squared in parentheses, times 6x minus 4. That was my low d high. Then we have, this is kind of really hard to do, isn't it? Minus high d low. Let's see if I can squeeze this in. What I'm going to do is, you know what? Let's rope this, put it all down here first. And we'll put that up there. This is what I'm doing right now. Now I'm going to move this to the left a little bit like this. There we go. This will give me a little more room. That's an equals equals. It's not a lot more room, but now we want low. Now we need high D low. High was 8x cubed plus 5x squared times 3x squared minus 4x times the derivative of low, which was 5, all over low squared, 5x plus 1 squared. That is the derivative. That's f prime of x. Again, when you've got trig functions and other functions in there, you can't multiply stuff out ahead of time. This would definitely be easier to multiply this, easier to multiply product, multiply before taking derivative here. But this doesn't work for anything, any other type of function. Finally, find the initial velocity. If s of t equals t over t squared plus 1. This isn't finally. I'm going to pause because I'm going to have to go do something real quick. I'll pause and come back and. Okay, time to finish this off real quick. All right, so we want to find the initial velocity. This is when we're looking for v of t when t equals 0. That's the goal. And remember, v of t equals s prime of t. So we want to do the derivative of that. So high equals t. So d high dt is 1. And low equals t squared plus 1. So d low dt equals 2t. So we have low d high minus high d low over low squared. So low is t squared plus 1 times the derivative of high minus high times the derivative of low over low squared. I've got t squared plus 1 minus 2t squared over t squared plus 1 squared. So that equals negative t squared plus 1 over t squared plus 1 squared. That doesn't clean up any. But v at t equals 0, we can find just by plugging in 0. We've got negative 0 squared plus 1 over 0 squared plus 1 squared. We end up getting negative 1. That's interesting. All right. Then one more fun problem. Where does f of x have a, let's write what f of x is real quick. F of x equals 4x squared minus 3x plus 2. Have a tangent line parallel to y equals 2x plus 3. So 4x squared minus 3x plus 2. You got something going on like this. It's a parabola that opens up. And we want to know where the slope is 2. Slope of the tangent line equals 2. And then where's that parallel to y equals 2x plus 3? That's what we're going through for. So the first thing to recognize is this is our target slope. M equals 2 is our target. So if we find f prime of x, we can find m at any point. And this is 8x minus 3. And we want to know, when does that equal 2? So add 3 to both sides. Divide by 8. We get x equals 5/8. Seems crazy, right? Turns out, let's see, if we factor f of x, this is 2x plus 1 times 2x minus 2. It has roots at x equals negative 1/2 or 1. Say that's negative 1, that's 1. Means it's crossing here and here. And so somewhere halfway between, it's got its vertex. It's doing something like that. That's probably at x equals 0.25. We could find out by doing negative b over 2a. We've done that before. Negative 3 over 2 times 2 is at 3/4. What? Oh, wait. Not 2 times 2. 2 times 4 is, so is that 3/8. That doesn't seem like it's halfway between, but okay. And so not 0.25. But that means that the slope of 2 is like somewhere right around here. That's what we found. And y equals 2x plus 3 would have been going like that up there. Actually, we want it to look like the same slope. So let's do something like that. So we can find where slopes are not necessarily horizontal. Earlier, we did the horizontal when it was here, m equals 0, but we don't have to always just find it there. We could be finding where it's parallel to some other line. All right, that's it for this. Peace.